In this video, we're going to go over determining the expected value of a situation or scenario. So expected value is an idea of determining what the average value would be on a situation. I'll just read what I have here. Determining expected value on a situation is a way of lacing the probability of the different outcomes and the cost to determine average long-term gains or losses. So I would like to emphasize that expected value isn't trying to say what's actually going to happen. When we work these expected value problems, what we're determining is what the average, a type of average of outcomes. If the scenario played over and over and over and over and over again, you would expect this would be a type of average of all the outcomes. So for example, if you're playing like at a casino and you keep playing the slot machine over and over and over and over and over, what could you expect your average outcome to be? Now, if you play the slot machine once, you may lose $5. I don't really know slot machines, so I don't know how much they cost, so I'm just making this up. So you might lose $5 playing it once. If you play it 10 times and the 10th time you hit the jackpot, then you walk away with a lot of money. But if you take all of the plays over and over and over and over and over again and calculate what the win-loss averages out to, that's the idea of expected value. Let's look at an example so you can see how it plays out. Alright, here we go. In an accident injury case, a company can settle out of court for a loss of $250,000 or go to trial losing $500,000 if found guilty and nothing if found not guilty. Lawyers for the company estimate the probability of a not guilty verdict to be 0.75 or 75%. Find the expected value of the amount the company can lose by taking the court case. So again, just stepping back from this and talking about the idea of expected value again, is whatever happens here, one thing will happen. So they'll settle out of court, they'll win the case, or they'll lose the case. And so that's not what expected value is talking about. They're going to pay $250,000, they're going to pay $500,000, or they walk away without paying anything except for the cost of going to trial, I guess. But when you're asking these questions, is you're kind of working the probability into it to say, hey, if this scenario played out over and over and over and over again, then this is what we should do. Really, for something like this, you would only be considering this if you're a company that has a lot of liability, and over the long run, am I going to break? What is the best decision here? So I like to set these up using a table, and the items I put in my table is the event. So when you're dealing with expected value, you're going to have multiple events that are possible. In this case, our events are they're not guilty or they're guilty. Those are the two events. The idea of settling outside of court isn't one of the events that's involved in the probability. When you're looking at the probability, that's about is it found guilty or not guilty. The out of court is a third thing for comparison at the end that we'll talk about at the end. So you have the event, and then you have the value of the event. So instead of writing event out every time, I'll use just an E. So the value of E, or the value of the event occurring. The next column we want to make is the probability of the event. So I write that using our probability notation, P of E. And then the last column is going to be the product of the value of the event and the probability of the event. And again, product means multiply. So the value of the event times the probability of the event. So essentially this column is going to be whatever's in this column times whatever's in this column. So it'll build off of the previous columns. No matter what the scenario is, these are always the four columns I set up. Sometimes the event itself, this guy, and the value of the event, those can be the same sometimes, but they're not in this case, and even if they're the same, I still do my 4 columns. Alright, like I've already said, our events are that we're found not guilty, or the company is found not guilty, or it's found guilty. Some people might think of this as winning and losing sort of thing, but guilty, not guilty, those are our 2 options. Okay, now the value of each one of these events. If they're found not guilty, then they have to pay nothing. So the value of that event would be 0. They don't get anything out of it, but they don't have to pay anything. For the guilty verdict, if they go to trial and they lose, then they lose $500,000. So we put the value of this event is $500,000, but they're losing it, so it's a negative $500,000. That's a loss of money. And it's important if you're losing money that you make on these problems that you make it a negative. If you're gaining money, you make it a positive, because both will be possible on some of them. Okay, so now we go on to the probability of the event, and that's given by the 75%. The probability of a not guilty verdict is 0.75. So not guilty is 0.75. And then, since there's only 2 scenarios here, the idea of a guilty verdict is a complement of that, or 0.25. And so sometimes you're going to have to figure out the probability by using that complement rule. Sometimes you'll know each individual one. It, again, just depends on the scenario, and you have to read the problem to figure it out. But there's going to be a way to figure out the probability of all the events. One of the things that does confuse people on this particular problem is they try to find a probability for the settlement, and there's not a probability for that because that's not one of our events. But if it is one of the events, then there will be a way to sort out the probability of it. So one of the things I always like to emphasize is this probability of E column should add to equal a 1. This isn't part of the process of doing it, but when you're working out your events, you're doing all the possible different things that could happen, and so the probability of all things considered is always 100% or 1. So this column should always add to 1. If it's not adding to 1, you've left out a probability. So you want to make sure that that adds to 1. I mean, sorry, if it doesn't add to 1, you've left out one of your events over here. And so if it doesn't, I always just encourage people to check, are you adding to 1? If so, you're ready to go. If not, then there's something you haven't considered. In this case, that's kind of a reverse logic thing because we got our second probability by finding its complement. But in the next example, you'll see that sometimes you have to make sure you have them all by making sure it adds to 1. Okay, in our last column, we just take the product or multiply what we have in these 2 columns. So 0 times 0.75 is 0. And negative 500,000 times a quarter is negative, don't forget your sign, 125,000. Alright, so that's the chart. Once we have the chart all filled out, then what we really needed from the chart is this information. But the chart got us there. And so what we do next is we add whatever is in this column. In this case, it's pretty straightforward because there's only 2 of them, and one of them 0, so this adds to a negative 125,000. Okay, so what this is saying is on a type of average, an expected value average, if they take this to court, they can expect to lose $125,000. And this problem hasn't taken court costs into account. If there were court costs, we would then also subtract those off to add an additional cost to it. But there's no assumption of court cost. So basically, if you go to trial, you can expect to lose $125,000. But if you don't go to trial, you're guaranteed to lose $250,000. So what that means is, win or lose, you're better off going to trial because you'll lose more at trial on average than if you were to just settle outside of court. Now, literally, if you go to trial and lose, you're going to lose $500,000. And so this isn't it isn't a way of deciding things if there's just one, this is a one-time deal. This is, if I'm faced with this scenario over and over and over again, on average, I can expect to lose $125,000 going to trial, whereas settling outside is $250,000, so I'm better to go to trial. Alright, so it asked to find the expected value of the amount the company can lose by taking the court case. I think also it's good to explain your reasoning on that. Sometimes you'll be asked to explain your reasoning, so I just wrote out a sentence here explaining what I've described. The expected value is negative $125,000, so it is better to go to trial in these cases because over the long run, the loss is less when going to trial. Now, I want to emphasize my wording on that. So in these cases, so the logic is assuming this isn't a one-time scenario. It's assuming that this is a pattern. So in these cases, you're better to go to trial because over the long run, your losses will be less by going to trial. So that's the thinking on it. It's not a one-case deal. One-case deal, I would say you should settle if you're guilty. If you're not guilty, you should go to trial and prove it. But that's my opinion on the matter. I'm not a lawyer. Alright, so let's do another example to see how this will play out with a game of chance. Alright, here's our example. A local raffle drawing will give out the following prizes. 1 $500 gift card, 3 $100 gift cards, that should be plural, and 10 $20 gift cards. Assuming all 2,000 raffle tickets were sold for $5 each, what is the expected value of one raffle ticket? Alright, so this is asking if you buy that raffle ticket, what can you expect to get out of it? So again, we're going to set up the columns the exact same way I did in the previous example. The event, the value of the event, the probability of the event, and then the product of the value of the event and the probability of the event. Alright, so there we have that, and then for our event we want to come up with all the different possible outcomes for this particular scenario. Alright, so outcome number 1 is we win the $500 gift card, and then the $100 gift card, the $20 gift card. Okay, and then that's what students usually have no problem with that part. The thing that they leave off is the possibility that they don't win anything. I find this interesting because this is the most likely possibility, but it gets left off when considering possibilities, which I think is an interesting thing about human psychology. You're focused on winning, and you don't take into account that you may lose. Alright, so those are all the possibilities that are happening. The other thing that bothers students is there are 3 chances to win the $100 gift card. That's not that the event occurs 3 times, because you're only buying 1 ticket. So you're buying 1 ticket, so you have the possibility of winning the gift card. The 4 possibilities for you winning, buying that ticket are you win $500, you win $100, you win $20, or you lose. The fact that there are 3 possibilities, that affects the probability of you winning, but it doesn't create another event. Okay, so here the value of the $500 gift card is $500. So this is, like I was saying earlier, the event and the value of the event are very closely related, but I still like to do them in separate columns. And then the value that you lose is you get nothing. Okay, so that's our value of the event. Now the probability of each one of these, probability is the number of chances you get what you want over the total number of possibilities. Our total number of possibilities here are that they sold 2,000 raffle tickets. So those are everything in the pot. There's 2,000 of them. So for the $500 gift card, there's 1 of those. So that's 1 out of 2,000. And then for the $100 gift card, there are 3 of those. So we have 3 chances out of 2,000 of winning those. And for the $20 gift card, there are 10 of those. So it's a 10 in 2,000 chance. Alright, and so then what are the chances of losing? Well, it's all the other tickets are going to be losers, and so far we've accounted for 14 tickets. And so the rest of them are going to be losing tickets. Alright, so that gives us 1,986 out of 2,000 losing tickets. So those are our probabilities. One of the reasons why it's really common to leave this row out is because of what we're going to do next. When we find the product, it zeroes out. But the cost of losing is not always zero. It just happens to be the case sometimes. But if you get in the habit of leaving that out, you're not really taking into consideration all the events, and it won't self-correct if the value of losing isn't zero. And so it's just a good habit to always keep in mind that there's a chance that you lose all out. And most of the time, it's the greater probability of all the options. Okay, so I don't want to reduce any of my fractions. The math is easier if you don't, unless you're leaning on your calculator, but now we're just going to multiply these across. Now multiplying a number times a fraction, we're just multiplying the numerator. So this first one I'm going to get 500 over 2,000, and then the next one I get 300 over 2,000, and then this one I'm going to get 200 over 2,000, and then 0 times anything is 0, so that zeroes out. So we found our products, and so that's really what we use to find the expected value. So the next thing we do is we add these up, and this is where not reducing your fractions are handy, because in order to add fractions you have to have the same denominator, and when we add them the denominator stays the same, so whatever we get is going to be out of 2,000. If I had reduced everything, I'd be dealing with different denominators, and I'd have to get a common denominator or lean on my calculator. So now I just add up the numerators. Okay, doing that gives me 1,000 out of 2,000. So that equals 0.5. So at this point, I want to caution you, because this is not your expected value. Expected value takes in all the cost involved, and so we have not taken into consideration the fact that we're spending $5 for the ticket. So if I win a $20 gift card, I'm really only up $15. If I win a $500 gift card, I'm really only up $495. So we have to take into account the cost. And the way you do that is once you figure out, okay, this average that we've worked out, you're going to subtract off the cost. So we have a $5 cost, and so that's going to give me that I can expect to win or lose. If I play, I can expect to lose $4.50. That's how that all works out. This was different in the previous example. Once we found out we added, then that was our expected value, but that's because the problem wasn't taking into consideration any costs. That's why I mentioned court costs, that they weren't taking that in consideration. Most of the time there's a cost to play, and you have to take that off. That's a part of the consideration. If there's not, you don't need to subtract it, but most of the time in life there's a cost for showing up and playing whatever game it is that you're playing. So once you figure out this number, whatever it is, then that's only your expected value if there is no cost. If there's a cost to play, you have to subtract that off, and then that gives you the expected value. So the expected value of one ticket is negative $4.50. So on average, people can expect to come out behind on this raffle. You could probably deduce that just by thinking about the probabilities, but expected value laces probability with cost. Now, a good use for this isn't necessarily for the consumer. Expected value is really used more in the idea of setting up a game of chance. So whoever's running this raffle has set up a good raffle, because it's not too expensive to buy a $5 ticket. Most people would be willing to pay that, but in the end, if they sell all 2,000 tickets, they stand to earn a profit because the expected value is negative. If the expected value was positive, then everyone playing could expect to win money which means that on average, the people running the raffle will lose. So it's the same thing with casinos. They want their expected value to be negative, and this is where you get the saying that the house always wins. In the long run, the house is going to end up having more money than the people playing in the house, and that's how they pay for all the lights. So that's the idea of expected value. It's not telling you what one scenario will play out to be. It's in the long run, on average, this is what you could expect the payout to be. So go ahead and give some of these a try and see how you fare.